Okay, guys, example number 4 says find the domain of y equals the square root of x minus 3. That means the stuff underneath the radical, x minus 3, has to be greater than or equal to 0. Right, Eddie? Good. So, Eddie, if I want to find the domain, I need to get x by itself. I'm going to add 3 to both sides. And the domain, telling me what all the x values are, is what? All real numbers, thank you, such that x is greater than or equal to 3. Excellent. Now, Jordan, when I do my table of values and I'm choosing my x's, can I choose 0? Because that's a perfect square. I can get 0. No, I can't. Thank you, because x has to be greater than or equal to 3. Right? Now, let's look at this, though. If I plug in 3, what do I get underneath, Connor? I like 0. I want the stuff underneath to be a perfect square. I don't need x to be a perfect square. I need the stuff underneath the radical to be a perfect square. I don't need it, but it makes it nice and easy to work with. So if I let x equal 3, then 3 minus 3 is 0, and the square root of 0 is 0. Done. What do I want the next x to be? What do you think, Ned? 4. Because 4 minus 3 gives me 1, and that's a perfect square. The square root of 1 is 1. Good. What do I want the next one to be? I don't know. I really don't. Okay, good. I think I got it now. Kyle? No, not 6. What do I want it to be, David? No, not 9. What do I want it to be, Aaron? No, not 12. Chris? 7, I like. Because 7 minus 3 is 4. And 4 is a perfect square. The square root of 4 is 2. Now what do I want the next one to be? Winslow has his hand halfway up and now it's back down. Eddie's got his hand all the way up.
12.
And Eddie says he wants it to be 12. All right? So Eddie says, let's make this 12. 12 minus 3 is 9. Square root of 9 is 3. Excellent. Now, let's plot these points and see what we get. When x is 0, when x is 3, y is 0. Oh, look. It didn't move the graph up. It moved it to the right 3 spaces. Huh. Okay, the opposite of that term right there, minus 3, it moves to the right 3, because that's what makes it 0. That's interesting. Okay, we don't need to worry about it, though. 4, 1, that goes right here. 7, 2, let's see, that's 10, 9, 8, 7 is 2. And then 12, 12's way out here. 12, 10, 11, 12 is 4. So the graph of this thing looks sort of like this. Now, what's the range going to be for this thing? Connor. Range equals all real numbers such that y is greater than or equal to 0. And it's not showing up. Greater than or equal to 0. There we go. All right, guys. Great job. Do your homework. And I will see you tomorrow.